Greetings and welcome, Internet friends. This is Mr. Waddy here. We're going over the Chapter 1 review for Big Ideas Geometry. So here's question 8 from the review assignment, and this is going to be an application of the segment addition postulate. The idea is that the little segments added together are going to equal big segments. So xz plus 27 is going to equal the larger segment 38, right? So equals 38. And once I set that up geometrically, I can now solve using algebra. So subtract 27 from both sides. Algebra play, and I get x equals like 11. Remember that when I write xz without the segment above it, it's referring to a number, which is length. So that's why I can use the equal sign. If I'm talking about the object itself, I would say xz, throw the little segment symbol hat on top of it. So that's something that we'll practice for the rest of the course, just being familiar with when am I talking about the object and when am I talking about a number that may represent some quality of that object. All right, here we go. Question 11. So here's two formulas we're going to need. So I will need midpoint formula, and the midpoint formula is easily remembered by just thinking about the average of the x's and the average of the y's, and that would be that. And the distance formula is cousin to the Pythagorean theorem. That's square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Goes over that whole thing. So it's usually a good idea to label your points. So I'll call this x1, y1, and x2, y2. Whichever point I call 1 or 2 does not matter. Once I make the call, I need to be consistent with their use. So the midpoint is going to be 6 plus 7 divided by 2, comma, negative 3 plus negative 2 divided by 2. So I get 6 plus 7 is 13 halves and negative 5 halves. This is a perfectly fine answer, but I can also get decimals if I want. 5 comma negative 2 5. So that would graphically be the middle of those 2 points. The distance is going to be calculated a little bit different. These points I can tell are diagonal of one another because they neither share an x-coordinate or a y-coordinate. If one of those pairs of x's or y's were the same, then I would know they're either vertically up and down from each other or horizontally oriented from one. So here we go. x2, 7, minus x1, 6 squared plus y2, negative 2, minus y1, careful of the double negative. I'm going to get rid of 1 plus negative 2 plus is also going to become positive 1 squared. So 1 squared is 1, right? 1 plus 1 is 2. So I'm getting the square root of 2 for the distance. That's the exact value of the distance. And actually, since I'm talking about the distance from S to T, I could also just have called that ST, square root of 2. And a decimal approximation, okay, this is the same as about 1.4. So the midpoint, its answer is an ordered pair, an x comma y, a location. Well, the distance is a number describing how long that segment. Let's see, here we go. Find the perimeter and area of the polygon with the given vertices. So I've plotted these points. Looks like it's a right triangle. Because these 2 points are horizontal, horizontally located back to one another, that is points right here, over 6 up 5 and back 1 up 5. Notice that horizontally aligned points will have this y coordinates. That's one of the ways you can yourself into that. If points are horizontal or vertical of one another, you could just count the boxes if you have a graph. So 5, 6, 8, yep, is that distance. The other route you can take is using the what I call the one-dimensional distance. So notice E and F both have the same x coordinate, so they're going to be up and down from one another. And so if I want to find EF using the one-dimensional distance formula, it is not this formula that I have to use. That's for 2. I just have to take the absolute value of the difference of their coordinates. So I'm going to use negative 2.5. So let's actually say I set it up this way. So subtract those coordinates, take the absolute value. Usually people will just do always the bigger minus the smaller, and then you don't have to worry about the absolute value. But I'll show you the case in which negative 2 minus 5 becomes more negative, right? Negative direction. So abs negative 7. So that is 7. That distance F 7. Now for this diagonal, when they're diagonally located from one another, I can't count boxes. I would have to use the distance formula. Technically, yes, you could use Pythagorean theorem at this point, but I want you to write this chapter is kind of about it. So use the distance formula for now. There is a way that because these happen across through the corners of each little box, that I could count the diagonals if I happen to know that each of these counts as a square root of 2 units, not 1. So I believe this is going to end up being 7. But let's use the distance formula nonetheless. And so this distance, I believe, is between E and G. I guess I'll label those. So E and down 2. And one of the ways I can tell that these 2 points by their coordinates are diagonal of one another is that neither their x coordinates were the same nor were their y. So GF, or the distance, right, from G to F is G, square root of negative 1 minus 6 squared plus 5 minus double negatives. And so I'm going to get negative 7 all squared. Still needs the parentheses here. Without it, you'll be wrong. And 5 minus a negative 2 is 5 plus 2. When I guess I didn't positive. I can't distribute a square root over a plus sign, so I do have to keep evaluating everything on the side first. Negative 7 all squared is 49, plus 7 squared is 49, and that is the square root of 98, which is an exact answer. I could get a decimal approximation of, which is probably going to be like 9.9, I'm guessing, because right square root of 100, 10. So this is, yeah, about 9.90, 9.89. But when I round to 2 places, it's 9.90. There is a way to reduce radicals. I guess I'll speed run that right now. I can actually break this down into the largest perfect square that goes into it. So the product of 49 and 2 is 98. And this square root of 49 is 7. I could also write it as 7 rad 2, which is the most proper way of writing that distance, but maybe you might not be as familiar with that route. So that's GF right there. All right, so we'll call that 9.9. So why do I need these distances? I'm finding the perimeter and the area of the polygon. So the perimeter is just going to be the side lengths all added together, right? So 23.9. and perimeter. We didn't have any units labeled here, but this would be measured in one-dimensional. And the area, this is a triangle, so I can do base times height. Remember, the base and the height are going to be perpendicular of one another. And since this is a right triangle, it happens to conveniently be two of the edges. So the area of a triangle formula is half base height, half of 7 times 7. And so I'll get an area of half of 49, which area of half 25. And the area is a two-dimensional representation. So this is squared. If this was in inches, this would have been square inches. If this was in miles, this would have been square miles. So that's how I can find those. So it's kind of using some of our old area formulas, but I'm on a coordinate plane, so I need to use distance formula to find some of the. All right, here's question 17. This is using, unlike up here, which was the segment addition postulate, little lengths add to the big. I'm using the angle addition postulate, which says that the two little angles, this angle, x plus 58, combined with this angle, 6x plus 1, is going to equal, guessed it, the big angle, angle A base A. So actually they gave me already a clue that value. That's so my equation is that these two things add together to be the big value. Now, don't just always assume that, right? Because also in this chapter, we have sometimes that the two little angles are equal to each other if this was a bisector, or sometimes they add to 90 if they are complementary, or sometimes they add to 180 if they were supplementary. So don't just always assume it's going to be the same format. You got to pay attention to which property or postulate of geometry, right, lying. But now that I've got this equation written, hey, we're back into the algebra, good old days of algebra. Negative 10x plus 6x is 4x. 58 plus 41, like 99, 111. Subtract 99 from both sides. 12. Divide both sides by negative 4. And I get x equals 3. Might still need to be practicing your algebra steps. I was writing them. So x equals negative 3, but they want me to find these angle measures. So what I'm going to do in order to find that is plug the value of x in there or in there. So if I want to find the measure of angle AB, and remember, throwing a little m in front of the angle symbol means I'm not talking about the object, the angle. I'm talking about a number that represents the measure of it, the degrees of that angle in this. So negative 10 times x plus 58 value here. So that's negative 10 times negative 3 is positive 30 plus 58 looks like 88 degree measure of angle A. And in order to find angle CBD, or right DBC, whichever way I want to call it, I could plug the x in here, or I could kind of use this setup. And now that I know that this part is 88, and I'm trying to find this entire piece, the measure of angle, I could, yeah, I'm going to do it that way. I'll write it this way. So I'm going to say measure of angle CBD plus the 88 degrees is equal to 111. I think that's a little bit easier. I could have just plugged it in here and done 6 times negative 3 plus 40. Whatever. Algebra this, and I will end up getting measure of angle C equals believe so. Like so. So now I've sufficiently answered the question. So don't just assume that you're done because you write solve for x. That might be your tendency, or the feeling that you have, algebratician, right? Okay, here we go. Let's keep cruising. Here's 22. So here's keyword. It says angles 3 and 4 are supplementary. Supplementary means they add to 180. And then they told me the measure of angle 3, and I want to find the measure of angle 4. So I'm going to say measure of angle 4 plus the measure of angle 3, 56 degrees, is going to be the big angle, in case supplementary, 180. And now I just algebra this. Subtract 50. Measure angle 4 equals that. All right, so 124 and 56. Yep, add to 1. Right. Oh, looks like I'm done. So maybe you have some more questions. Sorry, I'm not going to do those in this video. Feel free to write them below. I'll help my students in class, and best of luck on your test. Have a great day.